This is a bit of a silly video because there's really nothing much new. Remember our old situation where we were approximating this by a line. We split it up into a triangle. We said this is delta x, delta y, delta s. And we had that delta s was the square root of delta x squared plus delta y squared. Well, if we want this in terms of y instead, say this is some function g of y now. Well, if we want everything in terms of y, instead of factoring out an x, we can factor out a y. So if we factor out a delta y squared, what we're going to get after a couple things is this now becomes delta x over delta y squared plus 1 like so. And again, the slope for a function of x is a change in y over the change in x. But the slope for a function in terms of y, we turn sideways. It's going to be delta x over delta y. This is, as delta x goes to 0, it's very close to, it becomes the derivative with respect to y. The derivative of x with respect to y. Not something we usually think about, but it's true, right? There's nothing magical about x's and y's or y's and x's. We don't have to think horizontally. We can think vertically. It's the same mathematical concepts, just sideways. Okay. So really, we can have an identical formula for arc length, integral from c to d. And again, we can write this in its addition. We can write the addition in whatever order we want. Usually it's written like this, just so it's, if we switch the order of the addition, we get the same thing as the other formula. So it doesn't even matter whether it's in terms of x or in terms of y here for arc length. It's basically the same formula. Right? It's just, are you dealing in terms of y or are you dealing in terms of x? And we'll use that. Let's give you an example of it, and it should hopefully feel, this is still example 1, but now let's do part C. It should feel the same. Now we have some function g of y is 3y cubed, where y is going from 1 up to 2. Nice try, Jason. Let's see if you can draw a 1 this time. Great work. Okay, so we want to find the arc length. Again, all the instructions are the same as the last video, example 1. Find the arc length. Well, it's exactly the same, but now it's just in terms of y. And again, if you want to, you can think of this, right? A lot of times we replace f of x by y. Well, if you want to, you can think of g of y as x. It's the same thing, just sideways. So if we do that, we want to find the derivative of x with respect to y. We dy both sides. Feels really weird, but it's true. If we take the derivative of both sides with respect to y, we get dx dy, kind of weird, and then the power rule, 9y squared. We don't need to add anything after that with the chain rule. We don't need anything here because we're taking the derivative with respect to y, and y is our variable. It's almost identical, just using y's instead of x's and x's instead of y's. So then our arc length is going to be the integral. Y is now going from 1 to 2. Square root of 1 plus the derivative squared dy, like so. So when we simplify this out, we get 1 to 2, square root of 1 plus 81y to the 4th dy. Okay, this is possible to do by hand. The question is why? Why is this possible to do by hand when this wasn't? Because we know what this is going to look like. Oh wait, maybe it's not. Wait, I don't think it is. I mean, it is possible, but it's going to use chapter 3. It's going to use a trig substitution here. If this were also an 81, then you could do it, because then it'd be essentially a semicircle. But because it's not, it's an ellipse. Actually, you could use what you know about ellipses to do this, I think, with a fancy substitution. I think it's possible, but it's not intended. I'm not intending you to do this problem. The intention was that you'd use a calculator for this, okay? So again, for in class, for the homework, do it by hand if you can. Otherwise, use a calculator. For class, like quizzes and stuff, you will either be able to do it by hand, or I will just ask you to set it up. Please let me know if you're uncertain about my expectations for you. Okay, this one, we'll use a calculator. I think the book also intends you to use a calculator for this one as well. I'm just going to double check. Yep, good. Just making sure, because I think you could use the area of an ellipse and stuff like that, but I was pretty sure they did not want you to do that. So again, this is the curve, x equals 3y cubed. Looks like this. It's a cubic function, just sideways. All right. Fun fact, cubic function sideways is basically the same as a cubed root function. And in fact, if we did, never mind. I won't talk about inverse functions right now. But if we did the integral from 0 to 2 of the square root of 1 plus 9x to the 4th, 9y to the 4th, we'll get our answer of 8.630. Units cubed. And again, you could check our answer, because I just showed you this is from the book and I wrote the problem down wrong. It's an 81. I knew it was an 81 because we squared the 9. And then we correctly get that answer of 12. I wrote the whole integral down wrong, guys. I'm supposed to be writing this. I'm just making things up. Okay. If we type things in correctly, then we get the correct answer of 21.028. All right. And again, if we wanted to, this is y goes from 1 to 2. When y is 1, we have the point 3, 1. And when y is 2, plug in 2 here, we get 24. So 24, 2. So if we really wanted to approximate this, well, we could approximate it with a line. We could approximate it as use Pythagorean theorem. The x difference is 21, and the y difference is 1. We could approximate this with Pythagorean theorem and get 21.02. Whoa, very similar, right? Very similar here. But again, approximating with a line will give a smaller estimation than the true value. And again, we could literally graph the line that we're using to approximate it with point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. What's the slope? Well, it's the change in y. Change in y is going to be just 1 divided by the change in x, which was 21. So we're approximating this blue arc length with this white line between these 2 points. You don't have to approximate this. I'm just showing that, yeah, that's essentially what this formula is doing. But instead of using one line, it's using infinitely many tiny lines. And that's how you do it when it's in terms of y. Basically the exact same thing. You just use y's and think in terms of y. Okay, that's it. In the next video, we'll start talking about a different topic, surface area.